We have learnt all the concepts from the center of gravity. Now we are going to solve each and every question which is there in the textbook, so that we are going to learn the complete concept. Okay, without wasting a time, we'll start with our first question. Can the center of gravity be situated outside the material of the body? Give an example. Okay, if you have seen my explanation about center of gravity, this question is a piece of cake for you. Correct? Center of gravity can be situated outside the material. So the answer is yes, it is possible. Example, we'll take an example of a ring, any ring, like an engagement ring, all those kind of ring, any ring. You can take any ring as an example. Okay, so what do you mean by center of gravity can be situated outside the material? See, at every point of this ring we have mass, correct? Particles, that is why we have mass. So every particle will be acting like this. The mass of all the particles of this ring will be acting towards the center. So exactly at the center we have the center of gravity. So the answer is yes, the center of gravity can be situated outside the material. The example is ring. What is the position of center of gravity of a rectangular lamina and cylinder? Very simple. This is rectangular, then a cylinder. Okay, so what is the center of gravity for rectangular lamina? It is nothing but intersection of diagonals, the point at which intersection of diagonals, where the diagonals are meeting, intersection. Next, the center of gravity for cylinder, that is nothing but the midpoint of axis of the cylinder. See how easy the questions are. If you know all these concepts, okay, whatever I have taught in the explanation part, then all these questions are very easy. At which point is the center of gravity situated in a triangular lamina and a circular lamina? Very easy question. See, triangular lamina. Don't worry about that word lamina. Lamina, you take it as a shape. Okay, triangular shape. Instead of using triangular lamina, you think it as triangular shape. So where is the center of gravity for a triangle? Intersection of medians. So how can we find the median? From this vertex to here, from this vertex to here, and from the here to here. So this is the point we are going to get the center of gravity. How can we write it in the exam? Intersection of medians of a triangle. That's it. Next up, they are asking for circular lamina. Circular lamina. Answer will be geometric center of the circular lamina. That's it. Where is the center of gravity for a uniform ring situated? See, for a uniform ring, what do you mean by uniform ring? If you take only this part, okay, only if you cut this part, okay, you have to check the weight. Then if you cut the same size, that weight, and the one more piece you are going to cut with the same volume, that weight should be same. So that is nothing but at any point the weight remains same. For a ring, that is nothing but a uniform ring. For a uniform ring, where is the center of gravity? It is nothing but the center of the ring. That's it. So the center of gravity is not within the mass. It is situated outside the material. State whether the following statements are true or false. The position of center of gravity of a body remains unchanged even when the body is deformed. What do you mean by deformed? The size or shape has been changed, mainly shape. Deformed means the shape has changed. So they are telling, even though there is a change in the shape, the center of gravity remains same or unchanged. Do you think that is true? No, that is completely false. Okay, why? Because center of gravity depends upon only one factor, that is nothing but shape. As the shape changes, center of gravity also changes. So this statement is false. Second one, center of gravity of a freely suspended body always lies vertically below the point of suspension. So if you understand this question, okay, if you get an imagination, you will get the answer immediately. If you don't get it, I will explain through a diagram. Assume any shape, okay, any shape, okay. This is the point where we have suspended this object. This object is suspended, okay. Now they are telling center of gravity of a freely suspended body always lies vertically below the point of suspension. So it will lies somewhere below, right, somewhere here, somewhere, anywhere here, correct, anywhere here, that will be below the point of suspension. So this statement is true. First question we are not going to solve. Why? Because that is the definition of center of gravity. You can aramse find it in the textbook, first page only. State a factor on which the position of center of gravity of a body depends. Okay, what is the factor which affects the center of gravity? It is nothing but shape. As the shape changes, center of gravity also changes. They are asking you to explain with an example. Okay, take an example of a wire. Center of gravity of a wire is the midpoint of this wire, correct? Now this wire has a shape. If I change the shape, what happens? Center of gravity also changes. How? If I make a loop out of this wire like this, using a wire we can make a loop, right? Now the center of gravity will be here somewhere, which is outside the material. So what is the factor affecting center of gravity? Shape. This is an example. A square cardboard is suspended by passing a pin through a narrow hole at its own corner. Draw the diagram to show its rest position. In the diagram, mark the position of suspension by the letter S and the center of gravity by the letter G. You just have to draw the diagram. Very simple thing. So there is a square, correct? Square suspended at one point, one vertex. Okay, assume this is a square. A, B, C, D. So here we are going to suspend it. Assume there is a rigid body. We are going to suspend it through this hole. The point of suspension we have to name it as letter S. Then where will be the center of gravity? Center of gravity will be the intersection of the diagonals. So you write this diagonal and one more diagonal. This point is nothing but G. That's it. This will be for 2 marks. A uniform flat circular rim is balanced on a sharp vertical nail by supporting at its point A as shown in the figure. Mark the position of center of gravity of the rim in the diagram by the letter G. Again, it is a very simple question. Listen, it's a circular rim, correct? It's for a circular loop. Center of gravity will be not within the rim, it will be at the center, correct? Somewhere here, even though there is no mass. So center of gravity will be somewhere here. But they have given one more hint. It is balanced with a nail, okay, which is attached to a wall. So using this nail, this rim is getting balanced. Where will be the center of gravity? See, you need to understand one thing. When there is a suspension, the center of gravity will lies below it. You need to understand the previous question number 9, there was a true or false question number B. Okay, so you need to understand that this is the point of suspension. Center of gravity will always be below the point of suspension, anywhere here. That's it. Very simple question. Figure shows 3 pieces of cardboard of uniform thickness cut into 3 different shapes. On each diagram, draw 2 lines to indicate the position of center of gravity G. Very simple. If you know the list for a different shape, where is the position of center of gravity, then this question is a piece of cake. If this question is asked for 3 marks, aram se you can take the 3 marks in your pocket within 10 seconds. Correct? See, for this diagram, okay, assume this as A, B and this as C. For diagram A, figure A, you can take any quadrilateral, center of gravity remains same. Why? That depends upon only one value, that is the point of intersection of diagonal. See, I have drawn 2 lines. They told only 2 lines to follow. We have to draw only 2 lines so that we should get the center of gravity. So G. For the triangular lamina, how many vertex we have? Okay, we have 3 vertex. So you can take any 2. These 2 or these 2 or these 2. Okay, I'll take this one only. Only 2 lines you have to draw. So this is the center of gravity. Next, for the circle, see, from one end to one more end. So this will be the center of gravity. That's it. See, experimental type of questions will not be asked in ICSE board examinations, but if we ignore them, there may be a chance using those experiments we may get some questions. Correct? We are not going to get the experimental type of questions, but there is no rule that based on the experiment there should be no question. They may ask you questions based on this experiment. See, how to find the center of gravity for a triangular lamina using an experiment, that you can understand by the explanation which we have done. How to find the center of gravity for any irregular shape. This is a regular shape, a triangular lamina, but the method remains same, that we have explained in the other video, explanation part of force B, center of gravity. That was our previous video. That video is available in the description box. You can learn that method. See how easy the questions are. If you understand the concept, okay, aram se you can solve any question based on center of gravity. We will see you in the next video that is based on force part C. Thank you.